Welcome to the CSUN video learning module on writing balanced chemical equations. My name is Simon Garrett. In this video, we'll give examples of writing balanced chemical equations. This is part 2 and is focused on examples where the chemical substances are given as words and not chemical formulas. You won't need a calculator, but a periodic table might be handy. You should attempt part 1 of this video and review your notes and textbook before starting this part. Here comes your first example. Question 1. Write a balanced chemical equation for the reaction of magnesium metal and sulfur to make magnesium sulfide. Stop the video here and work out your answer. The first step is to write the equation in words taken directly from the question. In this case, we can see that magnesium and sulfur are the reactants. The product, the substance made, is magnesium sulfide. So the word equation looks like this, where the arrow indicates the change from reactants to products. The next step is change those words we wrote into chemical formulas. Clearly, it is essential that we know how to create the correct chemical formulas from names. Something we won't do here, but something you should definitely practice. In this case, magnesium is a metallic, solid element on the periodic table with the symbol Mg. Sulfur is a non-metallic, solid element with the symbol S. And magnesium sulfide is an ionic compound formed from a metal and nonmetal. Since the common charge on the magnesium ion is +2, and that on sulfur is -2, these create a compound with equal parts magnesium and sulfur, or MgS. Most ionic substances are solids. Making substitutions of chemical formulas for the words we wrote in part 1 is simple, and it gives us an unbalanced chemical equation. The final step is to balance the equation from part 2. Balancing means making the number of Mg and S atoms on the left, reactant side, the same as the number of Mg and S atoms on the right, product side. We do this by adding coefficients, numbers that go in front of the chemical formulas, and multiply all atoms in the chemical formula by the coefficient. If we look at the equation in part 2, we notice there is one Mg atom on the left and right, and one S atom on the left and right. So this equation is balanced already. The final answer is the same as the equation we wrote in part 2. Question 2. Write a balanced chemical equation for the reaction of calcium and liquid bromine to make calcium bromide. Stop the video here and write down your answer. The first step is to write the equation in words given in the question. In this question, we see that calcium and bromine are the reactants, and the product is calcium bromide. Writing the word equation gives calcium plus bromine, making calcium bromide. The second step is to change the words we wrote into chemical formulas and create the unbalanced chemical equation. Calcium in group 2 is a metallic, solid element with the symbol Ca. Bromine in group 7 is a non-metallic, liquid element with the symbol Br2. And calcium bromide is an ionic compound formed from a metal and nonmetal. Since the common charge on the calcium ion is +2, and that on bromide is -1, these create a compound with 2 parts bromide and 1 part calcium, or CaBr2. As usual for ionic substances, this is a solid. Making substitutions of chemical formulas for the words we wrote in part 1 is straightforward, and it gives us the unbalanced chemical equation. The last step is to balance the equation from part 2. Balancing means making the number of Ca and Br atoms on the left the same as the number of Ca and Br atoms on the right. But looking at the equation in part 2, we notice that there is one Ca atom on the left and right, and 2 Br atoms on the left and right. So this equation is balanced without adding coefficients. Again, the final answer is the same as the equation we wrote in part 2. Write a balanced chemical equation for the reaction of potassium and fluorine gas to make potassium fluoride. Pause the video here and work out your answer. The first step is to write the equation in words. In this question, we see that potassium and fluorine are the reactants, and the product is potassium fluoride. Writing the word equation gives potassium plus fluorine, making potassium fluoride. The next step is to change the words into chemical formulas and write an unbalanced equation. Potassium is a metallic solid element with the symbol K. Fluorine is a non-metallic gaseous diatomic element with the symbol F2. And potassium fluoride is an ionic compound formed from a metal and nonmetal. The common charge on the group 1 potassium ion is +1, and that on fluoride is -1. As such, the product compound brings together equal parts K and F with the chemical formula KF. We'll substitute the chemical formulas for the words we wrote in part 1 to make the unbalanced chemical equation. We can immediately see that although the number of K atoms is balanced, one on each side, there are 2 fluorine atoms on the left and only 1 on the right. We can add a coefficient before the KF to make sure that we have 2 F atoms on the right. This balances the F atoms on left and right. Note that we cannot put a subscript 2 after the F to make KF2. Although this seems logical and would appear to solve our problem, it changes the chemical formula for potassium fluoride from KF to KF2. This doesn't make sense. We know the chemical formula deduced from the charges on the ions is KF, so never change the chemical formulas when balancing. Only add coefficients. But wait a second. By adding the 2 coefficient on the right, we've upset the balance of the K atoms. We now have 2 on the right and only 1 on the left. So this is still not balanced. We can't change the 2 back to a 1 because we'll undo the work we just did. The only solution is to add a 2 before the K on the left side. The final answer looks like this, and is not the same answer as the equation that we wrote in part 2. Double check it's balanced before moving on. Question 4. Write a balanced chemical equation for the reaction of aluminum and oxygen to make aluminum oxide. Pause the video here and work out your answer. The first step is to write the equation in words. In this question, aluminum and oxygen are the reactants, and aluminum oxide is the product. Writing the word equation gives aluminum plus oxygen, making aluminum oxide. The next step is to change the words into chemical formulas and write the unbalanced chemical equation. Aluminum is a metallic solid element with the symbol Al. Oxygen is a non-metallic gaseous element, one of the 7 diatomic elements on the periodic table, with the symbol O2, and aluminum oxide is an ionic compound formed from a metal and nonmetal. The common charge on the group 3 aluminum ion is +3, and then on oxide is -2. The product brings together 3 parts oxygen with 2 parts aluminum to make the chemical formula Al2O3. We'll substitute the chemical formulas for the words we wrote in part 1 to make the unbalanced chemical equation. This gives us Al plus O2, making Al2O3. Finally, we'll balance the equation we wrote in part 2. It is not balanced as written. We don't have enough aluminum or oxygen atoms on the left compared to the right. To get the right number of Al atoms, we can add the coefficient 2 before Al on the left. To get 3 O atoms on the left, we can add the coefficient 1.5 in front of the O2 on the left. Try it on your calculator. 1.5 multiplied by 2 is 3. So we have a balanced chemical equation with 2 Al atoms on the left and right, and 3 O atoms on the left and right. But we're not quite finished. We generally don't allow non-integer numbers for coefficients. Chemically, this makes sense because it implies 1.5 oxygen molecules on the left, and we cannot have half a molecule. To get rid of the awkward 1.5, we can multiply all the coefficients by 2 to give the final balanced equation. Note that the coefficients are now all integers and the smallest integers in this ratio. In general, we write balanced chemical equations using the smallest integers we can. Before we move on, count the atoms of each kind on the left and right to make sure this last equation is truly balanced. Question 5. Write a balanced chemical equation for the reaction of hydrogen and nitrogen to make ammonia gas. Ammonia is a very important industrial chemical that is used to make plastics and fertilizers. Pause the video here and work out your answer. The first step is to write the equation in words. Writing the word equation gives hydrogen plus nitrogen, making ammonia. The next step is to change the words into chemical formulas and write the unbalanced chemical equation. Hydrogen is a non-metallic gaseous element with the symbol H2. Nitrogen is a non-metallic gaseous element with the symbol N2. And the chemical formula for ammonia is given in the question as NH3. Since this is a molecular compound formed from 2 nonmetals, we would not be able to predict the chemical formula based on ion charges. We'll substitute the chemical formulas for the words we wrote in part 1 to make the unbalanced chemical equation. This gives us H2 plus N2, making NH3. Lastly, we'll balance the equation we wrote in part 2. It's not balanced as written. We don't have enough hydrogen atoms, but we have too many nitrogen atoms on the left. To balance the H atoms, we can add the coefficient 1.5 before the H2 on the left side. To balance the N atoms, we can add the coefficient 0.5 before the N2 atoms on the left. The equation is now balanced, but we are not quite finished. To get rid of the 1.5 and 0.5 coefficients, we can multiply all coefficients by 2 to give the final balanced equation. The coefficients are now all integers and the smallest integers in this ratio. Again, double check that this equation is balanced by counting the atoms of each kind on the left and on the right. I think you're getting the hang of this now. Let's try question 6. Write a balanced chemical equation for the reaction of oxygen and carbon monoxide to make carbon dioxide. Carbon monoxide is an odorless toxic gas that can be produced by malfunctioning water heaters and furnaces, and all homes in California must have a carbon monoxide detector. About 1,500 Americans die every year from poisoning by carbon monoxide. On that cheerful thought, pause the video here and work out your answer. First step is to write the equation in words. Writing the word equation gives oxygen plus carbon monoxide, making carbon dioxide. Next, change the words into chemical formulas and write the unbalanced chemical equation. Oxygen is O2. Remember, it's a diatomic gas, so O2, not O, as it is written on the periodic table. Carbon monoxide is a molecular compound of 1 carbon and 1 oxygen atom, so its formula is CO. Similarly, carbon dioxide is 1 carbon atom with 2 oxygen atoms, and a chemical formula of CO2. We'll substitute the chemical formulas for the words we wrote in part 1 to make the unbalanced chemical equation. Lastly, we'll balance the equation. It's not balanced the way it's written. We have 3 oxygen atoms on the left, but only 2 on the right. This is easily fixed. If we add a 0.5 coefficient before the O2 molecule, then we have 2 total O atoms on the left. The equation is now balanced. but you should quickly recognize that we have to get rid of the 0.5 coefficient to make it an integer. The final balanced equation was obtained by multiplying all the coefficients in the previous line by 2. Another one. This one is a little more difficult, but still follows the same ideas. Write a balanced chemical equation for the reaction of methane and oxygen to make water vapor and carbon dioxide. Methane is natural gas, and this reaction takes place each time we turn on our stoves. Pause the video here and work out your answer. First step, like always, is to write the equation in words. Writing the word equation gives methane plus oxygen, making water and carbon dioxide. Next, we'll change the words into chemical formulas and write the unbalanced chemical equation. Methane is given in the question as CH4, and it's a gas. Oxygen is O2. Water vapor is H2O gas. And we already know that carbon dioxide is CO2 gas. We'll substitute the chemical formulas for the words we wrote in part 1 to make an unbalanced chemical equation. Let's balance the equation. It's not balanced right now because we have 4 H atoms on the left but only 2 on the right. We have 2 oxygen atoms on the left but 3 on the right. The first problem, the H atoms, is fixed by adding a coefficient of 2 before the H2O. This gives us 4 H atoms we needed on the right. But we are still not balanced completely because the O atom count is 2 on the left and 4 on the right. If we change any of the coefficients on the right, we make things worse. But we can go back and change the coefficient in front of the O2 reactant to a 2. This now gives us 4 O atoms on the left and right to complete the balance. The final balanced equation is shown. It does not need to be multiplied because the coefficients are already in the simplest ratio of integers. One final example, question 8. Write a balanced chemical equation for the reaction of iron 3 oxide and magnesium to make iron and magnesium oxide. Pause the video here and work out your answer. First step is to write the equation in words. Iron 3 oxide plus magnesium makes iron and magnesium oxide. Next, we'll write the chemical formulas for the substances and then the unbalanced chemical equation. Iron 3 oxide means the iron is iron 3 plus. The O in oxide is O2 minus, so the chemical formula for this ionic compound is Fe2O3. Magnesium is Mg, iron is Fe, and magnesium oxide is MgO, formed from an Mg2 plus ion and an O2 minus ion. We'll substitute the chemical formulas into the word equation we wrote in part 1 to make an unbalanced chemical equation. Let's balance the equation. It's not balanced right now because we have 2 Fe atoms on the left, but only 1 on the right. 3 O atoms on the left and 1 on the right. The first problem is fixed by adding a coefficient of 2 before the Fe, and the second by adding a coefficient of 3 before the MgO to balance the O atoms. That fixes it, right? Check carefully. We now have 3 Mg atoms on the right, but only 1 on the left. So add a final coefficient of 3 before the Mg reactant to balance the Mg atoms. Here's the final balanced equation. Again, all coefficients are integers and are already in the smallest ratio. So how was that? Let's review. The first step is to write down a word equation. Pick out the reactants and products from the language of the question. Write them down separated by an arrow. The order is unimportant. Write down the chemical formulas for all the substances you wrote in the first step. This is a common problem area. If you get the chemical formulas wrong, the equation will certainly be incorrect and may be impossible to balance. Watch out for elements like hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine that always occur as diatomic molecules. Substitute the chemical formulas for all the substances you wrote in the first step. This creates the unbalanced chemical equation. Balance the equation atom by atom by adding coefficients in front of the chemical formulas. Never change the chemical formulas. If your balanced chemical equation has non-integer coefficients like 0.5 or 1.5, multiply all the coefficients by the smallest constant necessary to turn them into whole numbers. Finally, double check that the equation is really balanced by going through one last time, atom by atom.